Okay, section 3 is going to be our introduction into exponential and logarithmic functions. Specifically, section 3 is on exponential. So here's kind of what we're looking at. We're looking at, with a polynomial function, we were looking at a variable x raised to a numeric power, like x squared or y to the fourth or z to the seventh. Okay. Now, when I switch that around a little bit, okay, on the other hand, we have an exponential function where our base is on the bottom, or our number is on the bottom, and our variable is on top. So 2 to the x power is an example of an exponential function. Now, a couple things. We're going to be doing a lot of evaluating in this section, but just a couple things to note. When you're given an exponential function on an xy axis, okay, what you get is a graph that comes along the x-axis, crosses typically at about 0, 1, and then shoots up. Okay, that's typical of an exponential function. Okay, so what we're trying to do here is we're trying to look at functions of that type. Okay, and like I said, the first part of this is just to be able to evaluate some numbers. Okay, now another thing they're going to ask you to do is start to write some answers, solve some equations. Okay, and the premise behind solving an exponential equation is if you know that you have a to the x power equals b to the y power, okay, if we know that a equals b, if a and b are the same number, then that means that x and y, the exponents, must also be equal. So what we're going to try to do in these examples is we're going to try to make situations where we force the bottom numbers to be the same, so that means we can set the exponents equal and solve. Okay, so you'll see that, and there's a number of different ways we can do that. Just a reminder of a few things that'll come up. Remember that if you have a to a negative exponent, okay, that means that we can take and write its reciprocal, or vice versa. Okay, if we have a fraction like this, we can take that a and bring it to the top using an exponent. Okay, we can also take numbers. If you have a number like 9 squared, and that is, well, okay, let's leave it like that, 9 squared. Okay, that's the same thing as 3 squared squared. Okay, the 9 breaks down to a smaller base of 3, so 3 squared, there's our 9 again, and then 9 squared, which is the same thing as 3 to the 4th power, because we can multiply the exponents together, okay, to get that result. Okay, so kind of the same thing here, some ways of forcing some situations where they keep the bases the same so we can set exponents equal. Okay, not a whole lot of problems here, and I'll show you a few just to get you started on this. But on question number 19, and 20, 21 are all calculator problems. And with your calculator, they want you to type it in and round it to 3 decimal places. So on this first one, let's see how well that shows up here. Okay. If I have, let's say B, 19B is 2 raised to the 2.71 power. Okay. Over here on the right side where you have the little caret key, okay, you can use that to express these different exponents. So I'm going to type in 2 and then use that caret key, and it pushes the cursor up into your exponent. Type in the 7, 1, and then hit enter, Okay, now note the e to the 21 power out here. Okay, you may have to use that as part of the expression because it will be so small. Okay, this is well, it's 2, and then it's got 21 decimal places after it. So this one's gotten really, really big, really, really fast. Okay, so oh, sorry, not to the 71. It's supposed to be 2.71. It didn't register one of my keys here. Let me try that again. Clear it. 2 raised to 0.71. That looks a little better. There and go. There, it's an answer. That's a little bit better. So it says rounded to 3 decimal places. So I would call that 6.543. Okay. So the caret key is used to express those. Now, you notice also the ones that have a base E. Okay. Remember that E is called the natural base. Okay. It is a number. It's like pi. It's like 2.71 something. I don't remember all the decimal places. It's irrational. Doesn't repeat, doesn't stop. And so if I wanted to go use that, there is a key on your calculator for using E. It's down here above the LN button. Okay. And so to activate it, you have to use the second key. Okay. So let's try 21. Well, let's do D first. Okay. Because you're gonna have to be careful with that one. So I want to go 2. Again, hit the caret key. And this time I'm going to go second and then go down to the LN. So it types in that E. But notice that it gives you another little cursor up above it as an exponent. Okay. It doesn't give us a number to fill in there. So what we're going to do is we're going to call it a 1. We're going to type in a 1 there and then hit return. Okay. Okay. So what they've done is they've taken the number 2 to the 2.7 power, and they've added a bunch of different digits for you to approximate ultimately what D is, 2 to the E power. So this one would be 6.581 when you round. 6.581. Okay. So I'm going to put those on the answer sheet here real quick. So for B, we ended up with 6.543. Okay. For D, we got 6.581. Okay. Now, on 20 and 21, you're going to use E by going second and then hitting that E to the X first, type in the exponent, hit enter there. Okay. Now, down below, number 23. Okay. Here's where we have to start thinking a little bit creatively. Okay. What I want to do on these is I want to create an equation where both sides of the equation have the same base, and then I can set exponents equal to solve. Well, a common base of 3 and 9 would be 3. So this would become 3 to the x to the third power. This would become 3 to the second to the x power. Okay. The two equations now have the same base, two sides of the equation. Okay. And the power rule here says I can multiply the 2 and the x together. So x to the third and 2x. And since the bases are the same, then the exponents have to be equal. So x to the third has to equal 2x. Okay. Now, what I want to do here to solve that, I want to find out what x has to be to make that true. So I'm going to subtract the 2x over. X to the third minus 2x equals 0. And now I can factor out an x. So x times x squared minus 2. Okay. If I set both of these quantities equal to 0, x equals 0, or x squared minus 2 equals 0. Here's my first answer. And if I add the 2 over and square root, I get plus or minus the square root of 2. Those are my 3 possible answers. Okay, so we're trying to force those expressions to have the same base and then set exponents equal to there from there. Okay, now go back to 22. I want to start you on that one, only because this is the other thing I was talking about with the notes. Okay, remember the 1 over 5, the reciprocal there? I can take that expression and rewrite it as 5 to the negative 1 power. Okay, that's the same thing as 1/5. Okay, now, since both of those have the same base, they both have 5s, I can now set the exponents equal. Okay, now solve that for x. Okay, 24 is going to look like 23. Again, make common bases there, and I would use 3s. Okay, 25, notice that they already have common bases. Okay, so common bases, they all have e. So I'm going to use another exponent rule. And I can take these e's, these are being multiplied together. But remember what the product rule says. Product rule says when you multiply, you can shorten those up by adding their exponents. So this can be written as e raised to the 4x plus x squared power. Okay, one e term. Okay, and on the other side, I have e to the 12th. Both sides have the same base, so the exponents must be equal. So 4x plus x squared equals 12. I'm going to subtract the 12 over and then rearrange the terms. So x squared plus 4x minus 12 equals 0, which is factorable. The factors of negative 12 that add to 4 would be 6 and negative 2. Use your zero product rule, set each equal to 0. Subtract the 6 over, add the 2 over. And there are your 2 answers there. Okay, so again, sometimes you have to get a little creative with those, but it's all a matter of creating the same base on both sides and then going from there. Now, again, these are ones that had nice integer answers. You have some problems that are going to be similar on the test. Again, remember my suggestion. After you get done with these, go to the same sections on the test and complete those while all this stuff is fresh in your memory. And that should make some of this go a little bit easier as well. Okay, so that finishes up this worksheet. Okay, we'll move on to section 4 and start talking about logarithmic functions and how they compare to these, and kind of do some work back and forth. But we do have another section on we're going to be solving questions like these. Okay, so keep that in mind for what's coming up in section 6. Okay.